Okay. All right, I'm gonna make myself go away here. All right, we are going to go through the bioavailability and bioequivalence quiz together. Okay, first of all, if the bioavailability of F is high, okay, so F is high at 0.85. That means that the FA must be large. Well, let's think about that. F is equal to FA, fraction absorbed, which is what we're interested in here, FG, and FH. All three of these are components and they're multiplied together. They're not added together, but multiplied together. And each of these can be between 0 and 1, right? So if these are all 1, this is going to be 1. If any of these is 0, this is going to be 0, right? So this could be 1, this could be 1, and this could be 0, and F will be 0, right? So if we think about it that way, if our product of these three things is 0.85, that means that the smallest of these is 85%, right? At the very smallest, only one component can be 85%. So yes, that means that they're all relatively large, right? So that is a true statement. The opposite is not true though. So if we said if FA is small, let's say it's 0.2. If bioavailability is 0.2, what does that tell you about these three components? We don't know anything about any of them other than at least one of them is relatively small. So FA could be 1, FG could be 1 or 100%, and FH could be 0.2, and then our overall bioavailability is only going to be 20%. So you have to think carefully about this before answering it. In order for a product to be considered bioequivalent by the FDA, it must have comparable, well, first of all, it must be pharmaceutically equivalent, which means it's the same therapeutic moiety, same dosing form, same amount, same dose, and same, it can't be different salt forms or anything like that. So it must be the same drug. And then have comparable bioavailability, and comparable is the key term here, to the reference drug. It must have 90% confidence interval that the Cmax, Tmax, so the maximum concentration, the time that Cmax occurs, so Cmax and Tmax, and the area under the curve, all are within 80 to 125% of the reference drug. It's just something you have to memorize. Pharmaceutical alternatives are the same therapeutic moiety, yes, but no, they don't differ. They have to be the same salt or ester form, same dosage form, and same strength. Pharmaceutical alternatives are interchangeable, but this part is not true. And if any of these things are different, then they will not be interchangeable. So this is false. Your patient is receiving drug M as a continuous IV drip at 85 milligrams per hour with good results. We need to change to an oral hydrochloride salt formulation of the drug with an F of 0.9 and a salt form of 0.65. If the oral drug is dosed twice daily, so we're going to give it every 12 hours, please determine an oral dosing regimen. All right, so here's where we want to have our initial salt form times bioavailability times dose rate equal to our new salt form, bioavailability, and dose rate. So since it was given IV and there's no salt form mentioned, we're going to assume these are 1, and the dose rate is 85 milligrams per hour. Our new salt form is 0.65, only 65% of it is the active drug. Bioavailability is 0.9, and so we're going to solve for our dose rate, aren't we? And this is going to be in milligrams per hour. Getting out my calculator. So, oopsie. So we expect this to be a larger number, don't we? Because we're going to have to give a lot more drug to account for the difference in bioavailability in salt form. So we're going to give 145.3 milligrams per hour as our new dose rate. And so if we're going to give that for 24 hours, we're going to have 3,487, 0.2 milligrams Q24. And if we're going to give it every 12, I'm going to divide that by 2. So it's going to be 1,743.6 milligrams Q12 hours. Okay, so round to the nearest 50 milligrams. So 43 is closer to 50 than it is to 0. So I'm going to give 1750. Okay, understand rounding to the nearest 50 milligrams. You don't always round down. I think some people maybe have told you that, but clinically we don't do that because sometimes it's more important that we make sure we're therapeutic, right? I mean, if you're treating cancer, you're treating an infection, you're treating epilepsy, maybe you're more worried about lack of efficacy than you are about toxicity. So it just depends on the patient, whether you're more worried about toxicity or lack of efficacy. So since you don't have that information, I would just always use your regular rules of rounding. Your patient HG has been taking tacrolimus, a 3A4 substrate, with his morning grapefruit juice for several months now. Grapefruit juice inhibits the CYP3A4 enzymes in the gut wall. He has decided he no longer wants to drink grapefruit juice and will change to orange juice. HG recalls that you, as pharmacist, telling him that if he ever changes how much grapefruit juice he drinks, he must tell you so. So he's telling you he wants to stop his grapefruit juice. So if we stop the grapefruit juice and the grapefruit juice is inhibiting, we're going to stop inhibiting. So we're going to see an increase in the enzyme activity, which means a decrease in the fraction that escapes the enzyme. So we're going to see a decrease in our fraction that escapes the gut enzymes. So what's going to happen? We're going to have what in his CSS average? Well, if we decrease FG, then we will have a decrease in F, won't we? And CSS average is determined by a bioavailable dose rate over clearance. So if our bioavailability decreases because we've got more of it being eliminated by these enzymes in the gut wall, we're going to see a decrease in CSS average. So we're going to see a decrease in CSS average. And what's going to happen to his peak to trough ratio? Well, no change, because peak to trough ratio is dependent upon K, which is really dependent upon clearance and volume, or half-life. You want to think of it that way. And as far as we know, those haven't changed. Okay. So the answer is decrease and no change. All right. We have another drug that's a substrate for P-glycoprotein in the gut wall, and a P-glycoprotein inhibitor that the patient was on is now stopped. Okay. P-glycoprotein, remember, once a drug gets into the gut wall here, here's the lumen, and here's the system, or here's the blood flow. Okay. So the drug gets into the gut wall, and then we have P-glycoprotein that's spitting it back out again into the lumen, right? So he was on a P-glycoprotein inhibitor, but now that inhibitor is allowed to repopulate. So if you have more P-glycoprotein, it's going to be less inhibited. So there's more P-glycoprotein spitting the drug back out here. We're going to have a decrease in the fraction that escapes the gut metabolism. So what's going to happen to the F of the substrate? the FG of the drug will decrease, and the F of the drug will decrease, right? We're also going to see a decrease in our CSS average, aren't we? How about peak to trough ratio? Do we expect to see a change in that? Nope, because as far as we know, we haven't had a change in clearance or volume, just bioavailability. Jason's been on 45 milligrams Q8 hours of defeat diabetes with a bioavailability of 0.57 for several years. He now needs to change the elixir form for a short time with a bioavailability of 0.87. So we have a higher bioavailability in the elixir, which means we'll need less of the drug, right? So please determine the dosing regimen. So we expect it to be less than 45 milligrams. All right, round to the nearest 5 or 10 milligrams. Okay. So again, we don't hear it, we don't see anything about a difference in salt form. So we'll leave that out. But we have bioavailability 1 times dose rate 1 is equal to bioavailability 2 times dose rate 2. Okay, so bioavailability 1 is 0.57, and you can do it by dose here or by dose rate, whatever makes you happy. Since we don't expect a change in dose interval, we can do it by dose. He's getting 45 milligrams, but now the bioavailability is going to be 0.87, so we solve for our new dose in milligrams. I got the new dose in milligrams to be 29.48 milligrams. And we're going to round to the nearest 5 or 10, so we will round to 30 milligrams every 8 hours. We're not going to change the dose interval. If the dose interval was maybe going to change, I would figure out the daily dose rate and then chop it up into however many pieces you need to. A change in the fraction unbound in plasma will cause a change in volume and bioavailability. Is bioavailability dependent upon plasma binding, plasma protein binding? No, F is FA, FG, and FH. So false. New drug Zippity Doodah has an area of the curve 0 to infinity of 130 milligrams per liter times hours when given a 500 milligram dose IV. All right, so IV, which is a bioavailability of 1. Please determine the F of Zippity Doodah oral when a 500 milligram dose is given in the following time concentration data is. So we have to go 0 to infinity. At 1 hour, the concentration is 12. At 4 hours, concentration is 8.5. At 12 hours, the concentration is 3. And then we'll have to do this in last dose or last concentration to infinity. So we have to break this down into rectangles, right? So our first rectangle is 1 hour wide. And what's the midpoint between these two? 6, right? So this is going to be, the first rectangle is going to be 6, and this is in concentration. This is milligrams per liter, and this is time in hours, yes? Okay, so what's the midpoint between 12 and 8.5? 20.5, right? So that's going to be 10.25. 10.25 times, this is 1, right? Times 3, so 10.25 times 3. So this is 30.75. The midpoint between 8.5 and 3 is 5 0.75, and we're going to multiply that times 8 because the width is 8, right? So this is 46. So our area to curve for these three rectangles is 6 plus 30.75 plus 46. So we've got 75, 2, carry the 1. That's 82.75, but we still have to figure out our distance between our last measured concentration to infinity. And that's going to be our last concentration, which is 3. It's C last over K, isn't it? So 3 over, we have to figure out K. So let's see, I would say rise over run. So natural log 3 minus natural log 12 divided by, what's the difference in time here? 11 hours. Yeah, we're going to have a negative number, but our K is not negative, is it? Get the natural log of that. So I got a K of 0.126. So 0.126. Take the absolute value of that and then put that in the denominator. So I got 23.8. So we're going to add 23.8 to our other piece there. And I got 106.55. And the dose of these two IV and PO are the same, so we don't have to worry about the dose, but we can say 106.55 milligrams per liter times hours divided by 130 milligrams per liter times hours. And I got 0.8196, so we're going to round that to 0.82 or 82%. So the F is 82%. You may have forgotten this piece. I don't know. The bioavailability of a drug has decreased. Okay, I like to write this down. Okay. The current regimen is 500 milligrams every 6 hours. What would you need to do to ensure there's no change in the CSS average or peak to trough ratio due to a change in F? Okay, so he's getting 500 milligrams Q6. So what is his current dose rate? It's 500 every 6, so he's getting 4 doses of 500, so it's 2,000 milligrams per day, right? And the tau or dose interval is 6 hours. So if the bioavailability decreases, what's going to happen? Well, our CSS what's going to happen to our CSS average? Well, our CSS average is going to decrease, isn't it? Because of the decrease in bioavailability. Therefore, we're going to need to increase our dose rate. We're going to need to increase it, give more of it. So that's going to go to, if we use the double and half, we're going to give 4,000 milligrams per day. What about our dose interval? Do we expect our peak to trough ratio when there's been a bioavailability change? No. So we're going to keep this at 6 hours. So we're going to keep giving it every 6 hours. If we want to give 4,000 milligrams a day and we're going to give it every 6 hours, we're going to break that up into 4 pieces. So it'll be 1,000 milligrams given every 6 hours. Okay, I hope that helps. We'll have those kinds of questions on our exam next week. So hopefully this helps you if you got confused at all. Thanks so much for working so hard. Bye-bye.